Welcome back everyone. We're playing scene 3 here. We're moving on from the two quadratic functions, one upward facing, the other one downward facing. And if you remember, we talked about the number of solutions rather than maximum possible solutions being 2, just because the degree here is 2. So you could have 0, 1 or 2. However, there's this question that came up in one of my classes. And the question is, yes, here's one quadratic, the upward facing one. What if the other quadratic function is like this? Okay, you see, so in this scenario it would be a maximum possible solutions could be 4, right? 1 2 3 4. All right, so I just want to clarify here. Firstly, if you have this horizontally aligned quadratic formula, okay, like this, it is not a quadratic function, just because when you run the vertical line test, you see it intersects at 2 points, so it's not a function. A. B, yes, it's still a polynomial, and these two figures do intersect at 4 points, rightly so. However, in this case, you know, this is equal to y square plus, let's say, 2y plus something, right? So the yellow one would have an equation such as this, and the purple one would have an equation such as this. So here itself you can see, if I substitute the value of y, see, remember how for any of the common points you take one equation and you substitute that in the other one. You take the value of y in one or the x in one and substitute it in the other equation. So in this scenario, if I take y as x squared minus 2 and I plug it in here, let's see what happens. X is equal to x squared minus 2 whole square plus whatever I have. You see right here, the polynomial is become x to the power 4 something. So the degree becomes 4, and that gives me the 4 solutions, which means I could have 0 or 1 or 2 or 3 or 4 solutions. So yeah, just wanted to clarify that. Then moving on, this time let's do our upward facing smiley quadratic function, and let's do our circle here. Equation of the circle, and let me just get done with this guy. We're done here. Equation of the circle is x squared plus y squared equal to 1. Okay, and then let's say the equation of the quadratic function here is x squared minus 2. So again, you could see either I could have this scenario, no solution, I could have this scenario, 1 solution, I could have this scenario, 2 solutions, or I could even have, let's say something like this, where the vertex could intersect as well as these 2 points. How about this, right? Let's make it a little, okay, so 1, 2 and 3. Okay, so these would be the 3 meeting points. And again, the 2 equations I'm dealing with is, let's take this one, y is equal to x squared minus 2. Remember how the red and the blue are both sitting at this point. These are common meeting points. So I could take this guy, the red, from here and put it here. That will give me a solution. Or I could take the blue, which is sitting here, and that would give me the solution here. So either way, this time to me, it seems if I just take the value of y from here and substitute it, bring it down here, that would help me. So let's keep the x squared the way it is, keep the plus the way it is, and in the case of y squared, I'm just going to bring this value down. And you can see the previous video, I think we covered substitution. So if I open this up again, x squared plus something x to the power 4, you see right here, minus 4x plus 4 is equal to 1, and you can solve this further algebraically, and you would see, since the degree is 4, I could have 0, 1, 2 or 3 solutions. In this case, if you solve this further, you would see the 3 points that we were talking about. Maybe we can cover another one. Let's say I take this off and I keep a line here. Again, so many scenarios, no solution, 1 solution, 2 solutions. Why? Because I'm gonna call this line, I'll keep the quadratic function the way it is, but I'm going to give the line an equation. Let's say y is equal to x minus 1. Okay, so again, remember what is the final degree. I can take these 2 points here, the green, okay, let's use blue instead of green. These are the two common, this is a common point, so is this is another common point, right? So remember how I can take this guy and move it here, and that means I can take the x minus 1 here, move it up, that gives me x minus 1 whole square minus 2, and with that, once I solve that, again it's a quadratic function and I'll get 2 roots. Okay, so we will stop here, and I'm going to leave you with a practice set. So please try those questions. Post your answers in the comments, and maybe we could have a YouTube live to discuss those questions. Keep watching, keep subscribing, and do sign up for sessions if you're interested. Bye for now.